Hello everyone and welcome back once again. This is your science teacher here, and this time I am here with the second part of chapter number 5 of grade 6 science Ncert textbook, that is separation of the substances. Students, as we already learned and discussed the first part of this chapter, and students, in the first part of this chapter we basically discussed about the different methods of separation of the substances like handpicking, winnowing, sieving, sedimentation, decantation, filtration, etc. Now in this second part of this chapter we will learn and discuss some more methods of separation of the substances. And students, in the last we will discuss some definitions that is basically help you to understand the basic concept of separation of the substances. So let's continue the chapter. So students, first topic that we are going to discuss in the second part of this chapter is use of more than one method of separation. Students, as in the previous part we discussed about the different methods of separation of substances, and we also discussed some examples where basically these methods were applied. But students, in some cases we often face with mixtures and solutions that cannot be separated by use of only a single separation technique. So students, in that cases a number of techniques needed to be applied simultaneously to achieve a desired result. Now let's take an example that will help you to understand more about it. Salt and sand mixture. Students, as you all know that both salt and sand weight almost about the same, and in fact their size also about the same. So students, here in the separation of salt from sand, neither hand picking nor winnowing will work here. So here we basically try to separate salt from sand mixture with the help of two techniques, that are filtration or decantation. And students, in the same way there are many mixtures where one technique will not helpful, and in that case we applied more than one techniques in order to achieve the desired result. Now students, let's discuss this case, means salt and sand mixtures, elaborately. So students, first of all, to separate salt from the sand mixture you have to take a beaker and water that basically contains the mixture of salt and sand. Now students, as you all know, the nature of both the substances, means salt and sand. When you take this mixture, the salt dissolves in water, whereas the sand deposits at the bottom of the beaker. Now students, the first thing after taking this mixture of salt and sand, you have to separate the sand from the salt solution with the help of a filter paper, as we discussed in the first part of this chapter in the filtration method, that filter paper has a very tiny minute pores that actually work as a sieve. So when you gently pour the salt solution through filter paper, then this filter papers will allow only the water to go through it. Now students, after separating the sand from the water, now you have to separate the salt from water, and for this you have to use simultaneously two methods of separation, and that are evaporation and condensation. So now you have to heat this salt solution in a kettle, and students, when you heat this solution you will observe that water or steam starts to rise from the spout of the kettle. Spout means the mouth of the kettle from where we basically pour the tea. Then students, once the vapor or steam starts to rise, then you have to just allow this steam or vapor to come in contact with a metal plate which has some ice on it. And students, as soon as you allow this steam to come in contact with a metal plate, then this steam gets converted to small drops of water which you have to transfer to another container and thus successfully manage to separate salt which gets left behind in the kettle and the water that you collect in a separate container. And students, that's how you can separate salt from its solution. Now students, the next method of separation is condensation. Students, condensation is the process by which water vapor in the air is changed into liquid water as soon as the water vapor comes in contact with cooling environment. In other words, we can say that the water in the air, a gas known as water vapor from your hot shower cold when it met the surface of the cold mirror, and this causes the water vapor to condense or turns into liquid form. As you can see here in this image, this one is the kettle here in this image, and the kettle basically contain water, and the water in the container starts boiling as soon as when it comes in contact with heat. And students, as soon as the water starts boiling, it evaporates waters in the form of water vapor, as you can see here. And students, when we allow this water vapor to comes into contact with a cold plate containing ice, then this water vapor again turns into water droplets, as you can see here and collected here in this container. So students, we can say that condensation is a process in which water vapors turns into water droplets on cooling. Now students, here is a question that can water dissolve any amount of a substance? Students, no, water can't dissolve any amount of a substance in it. For an instance, let's take the example of dissolving sugar in the water. Students, basically when you would put a small amount of sugar to the water, it would easily dissolve that in it. But as you would start increasing the amount of sugar, leaving behind the amount of water to be same, then you would start realizing that the frequency with which it was dissolving the sugar in it is decreasing slowly, and at last you would reach the point when if you would add sugar to that water, it wouldn't dissolve that. And students, this point is called the saturation point of the substance dissolved in it. Now let's take another example. Students, for example, if you continue to add increasing amount of salt to a small amount of water as you add sugar in water, then there will come a point that the salt will not get mixed with the water, and in fact the salt that you will going to add in the water, instead of dissolving, it will deposit at the bottom. And students, at this point we say that the solution has become saturated, means that it is now not capable of dissolving any more of the given solute, that is salt in this case. So we can say that water cannot dissolve any amount of a substance in it. And students, the basic reason behind the solution to be saturated is that as you add some substance to water, that substance starts occupying the space between the water molecules, and as you go on adding more and more sugar or salt to the water, it starts filling that space, and at last when it fills all the space present in that quantity of water that you take, then it stops and you get left with some amount of that substance left under the water. Now students, the question is that what is solute? Students, a solute is basically a very small element that is dissolved in a solution. As you can see here in this figure, here we take salt in order to mix it with water. So here the salt is a solute and the water is here solvent, and after mixing salt into water it will become salt solution. And students, as we discussed in the earlier slide, that if we add a solute in a particular amount of water again and again, then the solution will reach at a point that is known as saturation point, and after that point the solute will not dissolve in solvent. But students, there is a method by which we can increase the solubility of a solvent, and that is by heating it. And students, once we started heating the solvent, then the solution will help to increase the solubility of water, and hence then we can add more amount of the same solute again and again until we heating the solvent. Now students, as I said in the starting of the second part of this chapter, that at the last we will discuss some important definition that will enhance the basic concept of your separation of substances. So let's discuss each and every definition. The first one is churning. Students, I hope you all are very familiar to this process, and as you can see here in this image, can you answer me what this lady basically doing in this figure? Yes, you all are right. This lady is separating cream from the milk, generally by shaking it. So students, this process is known as churning, and we can define it as that churning is the process of shaking milk or cream in order to allow lighter particles to come to the surface in order to make butter. Now the next definition is pure substance. Students, pure substances are substances that are basically made up of only one kind of particles and has a fixed or constant structure, like gold, copper, oxygen, chlorine, diamond, etc. All these elements are mostly pure substances. Now the next definition is about impure substance. Students, the definition of impure substance is just reverse to that of pure substance. So we can define it as a impure substance is a substance that basically composed of or consists of more than one type of particles, like water, as it contains two particles, oxygen and hydrogen. In the same way, salt. And do you know what is the formula of salt? NaCl, means to say sodium chloride. Now students, the next important definition is about sublimation. Students, sublimation basically a process in which a substance directly convert from the solid to the gas state without passing through the liquid state. And the best example of it, naphthalene balls. Students, can you imagine that during winter season your mother basically kept these naphthalene balls between the clothes, but during next season these ball basically disappears from the clothes. Can you answer me why this happened? This is just because of this sublimation. Students, when these naphthalene balls comes in contact with clothes, they become heated up, and so they directly convert into gas state without being converted into liquid, and that's why these balls generally disappears. The next definition is about magnetic separation. Students, magnetic separation is another method of separation, and this method is basically used to separate metals from the mixture. and in this method the mixture is basically allowed to go through a magnetic belt, as you can see here, and as soon as the mixture go through this magnetic belt, then the metal just separated from the mixture being due to magnetic property, and that's how we can separate metals from their mixture. Now students, the second part of your chapter number 5 is completed here. Now I will be come back soon with another chapter. Till then, maintain a distance of at least 6 feet. Stay happy and healthy on your feet.